they were going to spend millions of dollars on, this was back in the late 90s. Somebody built a system for customer service where if you run this agent on the browser, actually if you go to this browser page, then the agent that you're chatting with can control your browser. So it's like instead of them saying, go to this link, the agent could take you to that link.
Okay.
They were going to, because we were in the inbound, outbounds, we were doing call center solutions at the time. So this feature would be huge at the call center because you don't have to fumble with somebody who didn't know technology. It was, oh, let me navigate your browser to that page.
Yeah.
They were going to spend millions of dollars on this thing. And my brain went, it can't be that hard. And so once I heard about it, I went to my desk, and within an hour, I had a Java applet running in the browser that I could control from another app outside of that. And I brought like the owner of the company over, and I went, come here, look at this. And he's like, how'd you do that? I go, dude, I just wrote this in like an hour. He goes, no, you didn't. I go, yeah, I did. Then he called Jose over, the CTO. He goes, look at what Bill just did in an hour. Dude, I totally killed that deal.
No.
And we built that feature ourselves. I said, dude, what are you doing? This isn't like rocket science, man.
Damn. That other company was like...
They lost $1 million deal, minimum $1 million deal on that.
Wow.
I said, I go, here's the proof. Shitty little proof. But we can do this. It's not like rocket science.
Yeah. Like, okay, it's possible.
Now, you don't see anybody doing that anymore because now the browser security is so locked down, right? But this is like early browser stuff. This is like 98 or something like that, where you can run a Java applet, which is basically a Java program in the browser that had full control over like
the Wild West.
Everything. And so if they went to that page and it loaded the Java applet and you would say allow that to run, right? There was some security there. Then essentially I could open up a WebSocket to that applet. That's basically what I did, and I can control the browser.
Okay.
But that's what they were doing. They weren't doing anything more than that, right? So
that's crazy.
No, but that's what your proof of concepts need to be. Like
like little.
Like do it in an hour. Look, shitty little thing. Blah blah blah. Look, prove that we can do it. Now let's build. Okay, we are live. Okay, today we're going to try to reproduce a bug that Ed has with image processing. Ed has, I don't know how many tens of thousands of images of deer that he's trying to process, and he wrote a little program. And he's telling me that ever so often we get a panic here or there, or model starts to go haywire. He's using the Gamma 4 model.
Okay.
So what I want to do is, because I can't get him to turn on logs, is just write a small Go program that does that one piece. It feeds the image into the Cronk SDK, asks it to inspect it, and I have the prompts that he's using, and then go to the next image. Now I've got 10 images. So we're just going to pretend those are thousands of images that we're going to process. I've added a little bit of extra logging now to this version of code that we have here because he did give me a stack trace, and the stack trace suggested that he sent in a request with an image and we didn't identify that there was an image in there. So we went down a text path and then it didn't work. But why that happened at that moment in time, nobody knows. So I'm hoping that if we write this little shitty program and just turn this thing on and crank it out for all these images over and over again, we'll potentially find this bug. I might even add a little parallelism to this just to push it a little harder. And we'll see. I thought it might be an IMC bug. But Ed is saying, which is even weirder, that without the caching on, it might even be happening more, which doesn't make any sense to me. I'm also curious if we're rebuilding the cache on every single request, only because the system prompt and the message is the same. The image is the only thing that's different. And so we're going to walk through some of this sort of slowly. But
Okay.
it'll be a good exercise. We'll write some cronk code and we'll try to fix some bugs along the way.
Yeah,
So
that'll be interesting.
So I think it will be sort of fun to do. And what I'm going to do here is we'll sort of hack on this inside of the cronk examples here. I'll just add a folder here, just called, I'm going to call it ed. And add a new file called main.go. We might need to make this a little bigger. And this will just be main, and this will be function main. And you know me, I'll just do an if. I can't type anymore since I don't write code anymore. It's freaking crazy, dude. We can even just do a log dot fatal here on the error. And then we'll do a function run, we'll turn an error, and if everything's good, we'll just do this. And this program doesn't really do anything right now, but if I come back to our terminal, maybe, actually I gotta come back here. Okay, so we'll kind of run the program in this space here. That's fine. Okay, so the very first thing we have to do is initialize cronk and get access to an API that we need. So I can steal, again, just, maybe I'll just use the vision. No, that's ISMA. The vision example here and just steal a bunch of crap that we need here, right? So maybe I'll do it this way. I can move it a little bit faster if I do that. So we'll just make this a global variable, but we're not going to use the quen, small quen model. We're going to use the Gemma, and I'm not going to use it in agent mode to begin with. All right, so that should be fine. I don't think Ed increased the context window on that. That's something we can look at. Okay. I'm going to need all of this essentially, right? Because I got to initialize the system and all that good stuff. So I can steal this code and I can steal sort of this code. And that gets me now being able to use gamma 4, blah, 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 blah. And now we can do our sort of run vision test, whatever I want to call it, right? And I can put a return on that. Okay. And then we'll have that function, turn an error. And for now, I'll just do a print line, hello test. And I'll just make sure that this runs, though we will need to pass in a cronk.cronk for sure, which I should have here. So that's good. All right, even though we're not using it just yet. And I should be able to just come here and do a go run main.go. And it should just do all that. And it should load the model, and it did, and now it's unloading it. And look at the size of the context window. That is like way too big. That might already be a problem for Ed. I don't think we need a context window that big at all. But let's just use it right now because that's what Ed is using.
Okay.
And that's what the GGUF data says. So we can definitely reduce some memory by reducing that. But you can see here, total RAM we're using is that, slot memory, model size. The slot memory is a function of how big that is.
We're using IMC.
And we're using IMC for sure. Where do you see that?
Down
IMC
there,
true,
yeah.
yeah. And I mean, these are all the default kind of settings here. So, and we're using 2048, 2048, which is interesting to me because I didn't set that up. So that's interesting to me. I'm shocked that's not 2048, 512. So I don't understand where that's coming from. Because if we go into model and the config, you can see here, these are sort of the defaults. So we try to run, we have some code that's supposed to figure out the best settings beyond these defaults. But because that is interesting to me, let's do the following. Let's do the following. All right, so you need to understand why this program is using a program. Why this program is using these model config settings, right? How did we decide on these? And we are using the, so that's, anytime I see something and my brain goes, right? It means I'm losing some mental model.
Yeah.
My guess is the code we have to determine the best config settings made this choice. I am not overriding any defaults. All right, let's just see what AMP is telling us here. It's not a bad number because we only have one slot, and so it's not bad to just pull 2048 bytes out of slot 1 and push them into the GPU. It's honestly not a bad option. I just don't know why we did it. So here's why those values were chosen, right? NBatch pure default. We're not in MO export offload mode, which would push it to that. So it falls through the define batch 2 times 1024, and we get applied. So
Okay.
NU batch tree, this is a giveaway that Kronk sees this as a vision model. Yes. In multi-file uses.
Oh, okay.
Oh, we had a default.
So if it's a
NBatch
vision model.
Hold on. Oh, it is a vision model.
Yeah, if it's a vision model, it's different. It's a different default.
Oh, I didn't even see this. Okay. So we're matching. This is why it happened.
Yep.
I didn't even see that config there. Okay, so that's fine, right? I mean, again, like I said, I wasn't upset with the number. I just didn't understand it. Okay, so this is a good place. We got the model loaded. The settings are good. The context window obviously could be smaller, but I need to stay in line with what Ed is doing. I don't think that's causing us pain anyway. And you can see we've got more than enough memory anyway. We're using about 35 gig anyway, so it's all good. Okay, so, okay, fine. Now, the next step is I have these images on, let me bring this up here, hold on. I have these images, this is the prompt that Ed was using, so maybe I'll just pull this prompt in now. I'll put it here just so we have it. Let me close this for a minute. So these are the prompt, this is the prompt that Ed is using right now, all right. what I'm going to do is just clean this up. I'm going to put it on a line that we can read it, but I'm just going to get rid of these breaks. Not that it ever really matters, but for me, I like this 80 column gutter for anything that we're doing that has to be sort of red.
Okay.
That's why I always have that there.
Yep.
And that works great with browsers. So if I have to look at this code in a browser,
Mm-hmm.
I know the browser is going to give me. And in the older days of computing before these fancy monitors, and we had CRT monitors, you only had 80 column widths anyway. So
Okay,
I grew up with basically this width.
Got it. Okay.
I forgot what this gutter is. It's like 120 or something. But if you go and you look in browsers, right, in a regular resolution for the average person, if you keep things within 80 columns, it ain't going to matter where you're looking at it.
Interesting. Okay.
So that's why that gutter's there. That's why I keep everything sort of in that realm. I mean, you can go over a little bit. You're going to be fine. But okay, so this is the prompt. You could see that he wants the model just to return a string, which he tells me he does it perfectly every time, and I don't believe it. but that's that. And then I have some deer pictures. Here. So if I bring the deer pictures up, hopefully everybody can sort of see them, even though they're small. So here are deer pictures. Well, here are pictures we've taken where we're looking for deer, right? And we can go back and look at the prompt. I don't particularly care about the prompt other than using the right prompt.
Yep.
But Kevin's like wishing he had his bow right now. I can tell right there. Dude, how amazing would that be right there?
Perfect.
And here's the stand, bro. So
Yep.
Shabbat! And it's looking at the stand too.
They're smart.
Yeah, but that's dude, look at that buck, bro. And look at the daytime. That would be, you wouldn't ever get that lucky if you were in the stand. You would never in a billion years get that lucky. I don't get that lucky. But this is mostly your view for the entire day.
Yeah,
right there.
pretty much.
That's it. That's your life.
It's 90%.
And you're
time.
cold. So, oh, look. There might be a deer in there. See a little brown in there?
Or a bird. Something.
Oh, no, it's just a tree. I don't know.
Okay, yeah, it looks like just tree.
Yeah. So anyway, here are images, okay? Why the camera went off, who knows? Maybe a bird flew through.
Yep.
Okay, so he's got like 15,000+ of these. I just took these 10. You can see they're all within a range of 200K or less, okay?
Okay.
So what we're going to do, and we're just going to do what he's doing one at a time with the one slot. We're going to pass this to the model with that prompt, give it back an answer, go to the next one, and just keep letting it run until hopefully it particularly breaks. Yeah. If it doesn't break within a certain amount of time, then I might go to sequence max 2, add a little concurrency to this, and see if we can get his experience. It might not be until you get through like 15,000 images that it starts to, like, there could be a memory leak somewhere or some problem. But early on, I want to study the logs a little bit to see what IMC is doing, sort of with the prompt. And I rewrote a lot of this image code because we had edge cases and things that were, some of the first code I wrote was processing images and it wasn't really good. So I've cleaned all that up. Anyway, so we've got things to look at here. Okay, so now the first thing for sure is I need to get a list of all of the images that we're going to be playing with, right? Okay, so let's do the following here. Okay, so maybe what I should do is run amp up here. Be easier for all of us. Okay, so running this program and I am lazy. Okay, I need a function that will return. Actually, what do I really need? I need a function that will return the list of files under the folder in this constant. So write me a function that will return that slice of string. Right? We could try this with the Coin 3 model and Cronk, but I don't want to waste time.
Yeah.
It's just not going to be as fast, right? And so that's fine. So let's just have it do that, because my brain doesn't want to start looking at Google again to do a file path. I know what the code's going to look like, but off the top of my head, it's going to take me longer to sort of write that than
if we just
than it just doing this.
Exactly.
Okay, so look, it read the directory, it iterated over. I wasn't even thinking that. This is even better. And we now have a list of images here, right? So maybe we rename this to image location.
Yep.
And then images with a potential error, and we have our list images.
Yep.
And we could be smarter and pass that in, like if we wanted to be even a better citizen here, right? We wanted to be a better citizen here. And if error doesn't equal nil, then we can just return a func.errorf, right? And I always just like to just say list images with the error. We know what got called. And you do that, okay? So we now have the images, okay? And that's good. Maybe we just do a quick func.println number of images %d, and we can do a length of images, right?
Yep.
So we know it's not 0. And it's complaining because I did a print line instead of a print f, and we need a d there. And we probably should do a check if length images equals 0, then we'll just return another error, right? No images to process. Now, this is what I always struggle with from a Go perspective. We're using error F, and there's no formatting, right? And so I guess if you wanted to be technically correct, you could bring in the errors package to do that. But now I got to bring in another package to do that, right? And I think old Bill would have been OCD enough to say this is the most accurate way to do it. But I think relaxed Bill says, why don't we just maintain consistency for errors, regardless if I have a format or not, right?
Just use error.
Okay.
Yeah.
So we now have a list of files that we're going to process. It might be good to just even run this program right now, just to see that that number was, that we can read that location, because I've got security issues with terminals. Like I can't read the downloads folder, and I don't want to be changing security things on it, but I think I can read the documents, which is why I moved it under documents. So, okay, good. Number of images, 11. The only other thing I think we need to do here is I run the...
We need to break it up.
Yeah, I just need another sort of print here. Not a print line, because then I can just do a... Like, just give me a couple there, and then maybe just say starting program, right?
Yep.
Do 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 do
Yeah.
Didn't it feel like it loaded earlier? Okay.
It did.
All right, starting program.
Okay.
Now, how did I get? Oh,
Oh. Yeah.
okay. I'll try it again. Okay, starting program. Or even the starting program is kind of silly. Maybe I'll just do this and it'll be enough. Okay, so I could even follow my own naming, my own sort of convention here, couldn't I?
Hyphen. Yep.
And I still want the carriage return, but maybe I do that with the
Space.
right, because then when we run this, it will just look a little cleaner. Been working on Go on the back end for quite some time now. Design labs keep needing interns. We don't really hire interns here. We just don't have the bandwidth sort of for that. And unfortunately, our clients are
Yeah. There.
not in line with that either. But so that's always a bummer to me. Okay, number of images 11. Now that's bad because my guess is that there's a DS file in this folder because I copied, you know, that dumb DS.
Oh. Okay. Yeah.
That dumb DS thing, right? So I think what we're going to have to do here is say if the entry.name equals .ds, what is it always called? Yeah, I can look at it here. Hold on. Let's go to, I said downloads, right?
Documents.
Oh, document. DS store.
DS.
What a surprise, right? Like, I hate DS stores. I thought I found a way one time to stop the Mac from creating these damn files, but I was wrong. So actually, let's just do this. If is directory or equals that.
Yeah.
We get rid of it. And now if we come back here, it should say 10. I hate DS Store, man. There was some low-level Mac thing that I read that would stop producing it. And I turned it on and reproduced, and I felt like for a long time it was working. And then suddenly these damn files started coming back. So if anybody knows a way to stop the Mac from writing these silly files, that would be great. Okay, so now I've got, oh dude, look, I didn't do our image. Dude, what's up with this, man?
What's that? Oh,
See? Here I did 31 with a nice, I always thought that took the same setting for
I
some
thought it
reason.
did.
It was for a long time, but there we go. I want everybody to, we need a professional show here where we're going to be showing behind the scenes. Come on now. But I always thought it just shrank that. Anyway, let's get back here. Enough of this joking around here. Okay, so we now have the 10 images that we're going to be playing with. Now the key is to iterate over each one of these images.
Yep.
And I'll come back to stealing some code here that we're going to need. Okay. Now, I'm not going to use the chat streaming. I'm going to use the regular sort of chat call here.
Okay.
So we know we basically have to do each one of these, right?
Yep.
So we're going to have to, it's funny that my little, I have a read image function. Let's see.
Read image, yeah.
So let's steal that. Now the problem with this little function is it does check that it's on disk. It reads it. I'm assuming, yeah, and this must close the file handle for you because you just get back the raw image. Okay, so that's fine, right? So what I now want to do is essentially
loop through it.
Yeah, but I want to do it like 15,000 times or something.
Yeah, crazy number.
Yeah, some silly number, right? I'll have to hit Control C anyway, but, and so, okay, here's the next thing I want to do. I don't think we should just iterate over the images. We should randomize this a little bit, right? And so what I want to do is choose a random number, right? So I don't know what variable to use right now, so I'll use I. Now there is a rand package.
Yep.
They used to have an int n, and that will give you a number from 0, including n, but not, which is fine, which would be the length of the images. So now we're going to get a value between 0 and 10, which is perfect. The Go team's always like, because everything's 0 index based.
Yeah.
So now we're going to number between 0 and 9, which is what we need. And we'll let that determine which image we're going to use,
Yep.
right? And so we can argue that the image we're going to use is images sub I. That's the image we're going to play with. I know we don't need the extra code there, but let's just keep it for now. And now we've got to read that image, right? So maybe what we'll do is this. That's the image file, right?
Yep.
And that gives us back the raw bytes for that particular image. It might be nice to log. The problem is yeah, whatever. We've got to see how much logging we do. So image that we're selecting is this one right here. That's fine, right? If we really wanted to be a little bit more accurate, we can call this the image files, right?
Yep.
And then this is like, we're not
Image
using this yet,
index or
image data itself, right? Like just to be a little bit more sort of accurate. So we got our image file. So this is like the image file we're going to be processing. And then that's the image data. Now what we need is a model D to perform the input. Now, we have a system prompt too, right? So I have to do this a little differently if I'm going to have a system prompt, because the messages at that point become a slice.
Okay.
Now, I have another example for the talk for tic-tac-toe where we are using a system prompt. So what I can do, again, why try to remember everything when we can just steal some code here? This is even better. That's what I want right there. So what we can do, I'm just going to put this in here for a second, is we define a document array. We'll have the role, but in this case, what I'm going to do, now Ed isn't using image message. He was using the raw media message.
Okay.
Okay, which is fine. Okay, like this is the OpenAI format for this.
Okay.
But he was using that, which is fine. I want to try to stay within the scope of what he was doing.
Mm-hmm.
So then we've got a prompt, and then we have the image data here. Now, a raw media message returned, it returned a slice. So for me to use, see, this is then bad because I don't know how Ed was doing this then, because messages is a slice.
Okay.
I have this returning, come on, a single model D, right? And this is returning already a slice with the two.
Yeah.
And so usually this would just go into this directly. Now, if I kept with what I was doing with my vision example for a second, I use this, which returns a single D. Oh no, this returned a slice too.
Slice.
Image. Okay, so this is interesting. So I don't know how to code this sort of off the top of my head, because ideally I need to append this into this. So this is where I have an idea how to do it. I don't know what's the best way to do it.
Yeah.
So why don't we ask AMP? Okay, so have to me, this is a failure in the API that I've written for cron.
Oh, okay.
Problem, right? I need to add a system prompt and a media message, and the API doesn't seem to be compatible with this. So, what's the best way to construct the model D? So to me, this is a flaw in the API because I've never had to do this before.
Okay.
Now, most likely what it's going to tell me to do is move this up here, is my guess, and then append to that up there and then assign it to messages.
Okay.
This is going to be my guess. But sometimes it comes up with some better, clever ideas. But it's a bummer to me that I can't inject this directly while you're working with Model D, because you want everything like embedded in there for better readability, right?
Okay.
But what a surprise. It did exactly what I thought it was going to do. Right? Create that first and then do that. Now, this is interesting to me because ideally what I want is everything sort of inside the Model D, right? And so right, because that's the append. So append requires, right, the slice that we're going to create, this, and then the append. So, but that's kind of ugly for me, right?
Yeah.
So, and it will work, right? That's what I want, yeah. I would like a small helper to make this scenario more user-friendly, and we can do everything inside Model D. So,
okay.
because that sucks, man.
Yeah, to have to do
right?
the append every time.
That sucks. See, where I was going originally would have been so much nicer, right? To do something like that, because that feels much better,
Yeah.
right? Now, it is going to write models is where we keep all the models.
Okay.
Oh, it's going to add a messages helper. Interesting. And then with our messages helper, we would then have, yeah, how much nicer is that?
Yeah.
I mean, that's what we wanted, right? And
That's
this could have been the other one too, an image message, right? It could be both.
Got it.
But that's what I wanted, right? So model messages, and now we can do any. Okay, that's a beautiful little.
Nice.
little
Yeah, it just
fix,
it flattens it out for you.
Yeah, I mean that's what we want.
Yep.
Hide the work that we have to do. Okay, so now we've got our system rule, and we have our prompt with the image data for that given image. Now the next thing is for us to do a call, but I don't want to do chat streaming. I'm going to go again and go back to this and steal the non-streaming call here,
Yep.
right? So let me just steal all that code for a second. So I like the idea of model thinking. That's fine. We need a context because you need to have it bare minimum timeout. And I'm sure, and that's way too big of a context, but we can put it here. I mean, that's like 5 minutes, man. If that happens in 5 minutes, we got big problems. Okay, so I got a context, we got a model D, we do that. Now, we can log the model response. I might just leave all that on one line. And then, honestly, this is all I care about at this point, right? And then I want to move on to the next. Or I want us to return an error and shut the program down, and we get the error. So this is basically the program that we need. But I need the extra logging that comes with cronk. But before we do that, what we're going to do right now is just run this one time. Okay?
Okay.
Let's just make sure that given one image,
It actually runs. Yeah. Loading model. It picked an image, image 5.
and it said none.
None.
And image 5 is none. So that worked, right? Like,
Yep.
beautiful thing, that worked. And then from an output perspective, maybe we do that, and then we'll have everything we need. Okay, so that worked. It ran, model response was none, and then it sort of finished. Okay, so now the key is to, oh, now there's a couple of things I didn't do here really. Let's enable thinking is false. We don't need any thinking. Don't waste time doing any thinking. I think all the other numbers are fine, though I know for a fact that we probably should be using 164.95. Let me just steal this, though I don't know what Ed is using, but ideally
But that wouldn't necessarily change.
that's not going to cause
yeah.
the other bug, but let's just, and I have to ask Ed what he's using here, so just for more accuracy based on what we know about this model.
Yep.
So this will run the one image. Let's just make sure that runs that image again. So you see how fast we built this thing. I mean, obviously I'm stealing a bunch of code from
Yeah.
examples and stuff, but
None. Image 9 that time.
and image 9 is none.
Let's see if image 9 has one.
No, there's
No.
nothing there. Okay. So the next thing to do, oh, this is interesting. Auto. I wonder what the actual, this should have told me, okay, this is something else to look at later. I would prefer when we're logging that to see the actual value that we chose. That's like super important. And that's from the model config. I don't know if I get this in model info. No. So, all right, just remind me before we're done, because
Okay.
I know I logged this stuff on the KMS side, but seeing auto doesn't really help me per se, because I really want to know what the value is. Okay. Anyway, we have this working. So now the key is to turn the cronk logging on.
Okay.
So to turn the cronk logging on, we've got to do it here. But I need a function that sort of supports that. So the idea would be model.with log.
Okay.
And it needs a function that implements the app logger. And of course, that's blowing up here. So if I just do this for a second. I might be able to, no, it doesn't want. I need a function that implements this type, and I'm trying to get to this type just to make my life better, but it's not, but I know where it is. It's not a big deal. I just don't know why I can't get to it faster. So here's app log, and it's essentially a function that looks like this. Okay. Oh, maybe because of that. Now, this is in line with like how slog works and all of that.
Okay.
However, we might be able to just use the default fumped logger, which knows how to do all this already, to standard out. So I should be able to then just say cronk.fumpedlogger.
Get rid of that. Yep.
Though that's interesting because I saw this in app log. So that would mean that, yeah, it's just an alias to the same thing. For backwards compatibility with the API as we learned more.
Okay.
So it's just an alias at the end of the day. So that now will give us the detailed logs that I want. So the first thing I want to look at is just to process 2 messages and then look at what's happening in terms of the IMC. Like how much of this are we actually reusing or rebuilding in terms of a cache, okay?
Okay.
So I've got the logging turned on. It looks like I also have, I wouldn't expected to have seen this in this log because, oh, this might have been what we just added. I just added this because, what line is this being logged on? Hold on. I added some extra logging to try to find this bug, but this, unless you turn on insecure logging, we shouldn't be showing it.
Oh, okay.
So, yeah, I'm not marking this with some sort of marker either in the logger. So I don't know where. It's interesting that I'm using this for the first time in this particular way, right? So I don't know where. I almost need this to see where each one starts and ends.
Yeah.
But this is this log that we're seeing here, I believe. Pre-tokenize. Okay. I added this to help us sort of find this bug. I can't leave this in the code, not like this, unless I have insecure logging sort of turned on.
Okay.
Which I don't. But we're doing this primarily to see if we can track down what's happening here. At some level, either an image we're not able to tokenize it, and so we think there's an image, but there isn't, and then we're going down the wrong sort of path. So I can't, this I want to keep in here. But this logging, only because we're logging prompt head and prompt tail, it would be too insecure unless I wrap this around an insecure logger marker. So I can do the following. If I wanted to leave this in here, I'd have to only turn it on, but I don't think I really want to leave it in here long term. But there's some good information here. We're seeing the beginning and the end of the I'm just pausing because I'm reading it just to triple check something that I may or may not want to do. So this is the beginning of the first few bytes of that prompt. We're taking the first 256. And here's the last sort of 256 of the prompt. Why I'm pausing is because I don't know when we're supposed to see a media marker in here. And I don't see any media marker in here. So I'm going to ask the model this right now first. I need to understand that log. And if we're going to ever keep it, I got to wrap it around an insecure logging flag.
Yeah.
also do for the next run is that. Okay, so what I'm curious about and we did an IMC cache hit true on top of that. Super interesting. Wait, let's start with this first question because I don't have a mental model of this right now. I would have thought that, and this time it found a bug. So that's good. But I don't, my brain is saying I should see a media marker in here and I don't. So I don't, I've lost some mental model of this. Okay, so.
Okay.
All right. Okay, so I see a log entry for the, what did we call it in here? For the diagnostic logging. Diagnostic logging. I was under the impression I would see the media marker in this templated in this prompt after templating. So why is my mental model wrong? And then I'll give it that log. Let it help me understand this a little bit more. You can see this model does a turn. Thaw channel. And this is always the same. The other thing I want to look at is when we do the next image, I'm going to do 2 next time, what's going on with IMC? Like, what are we keeping? What are we rebuilding? Look at the log field. Request was classified as media, but by the time that runs, no media bytes are attached. Cache match for slot 0 covering. But this was the first request. See, I think this is weird. Okay, we're gonna do the phone. Okay, but I only ran 1 request. So I am going to run this again and give you the full logs. And just to make it even simpler from a logging perspective. Okay, so let's run this again. I'm gonna get rid of that extra space. It didn't actually make my life any better. The only thing we could enhance here would be a date time or something.
Yeah. Yeah.
But it's okay. You know, we could do so I think that's how we do it on the.
Okay. So
I
consistency.
don't know if that's going to affect anything else I'm doing, but But at least there you know it's a cronk line.
So
Okay, let's come back here for a second. It is one request, not two. The two applied template calls and the two tokenization blocks are two phases of the same request. Oh, that's right. Okay, so here's the flow. Message is going in 3 entries. System raw media, which expands to, that's right, phase 1. So there are 2 phases because in the first phase, we have to build the cache.
okay.
And then we have to process what's in the cache. So,
Okay.
So,
Okay. that makes
so
sense.
what this is saying then is IMC media cache build, right?
Yeah.
System plus image from the cacheable prefix.
That contains 1 media marker.
Yeah, because
Okay.
we handle the system prompt sort of separately.
Got it. Yeah.
And then render system plus message to a 238. So on the first pass, we had that in there. But now MG token splits that into 3 chunks. System prompt, image, text. Get decoded straight into slot zeros. Suffix tokenizer. Remaining message 2, your trailing user text plus the assistant is what's left to add. That's the 3 user media, fetch request already consumed. So if it were truly 2 requests, you'd see 2 distinct, right? We don't. So 1 request, 2 internal templating passes, cache key, actual render, and 2 KB. Stuff's so complicated. Okay.
So 2 distinct start lines.
Okay, so then my question is, so then what is this diagnostic log helping us with?
Yeah. I mean,
The problem is that we run it through the template in order to identify what we can cache, but we always have to leave the very last message uncached for processing, because now we got to actually get into a processing loop.
okay.
So when the processing starts, we have to template again, but the bulk of what's already been sort of decoded is already in the cache. We've got to do this last message. It's kind of complicated. Process that, and then we can return. And then on the next request, that message gets processed back into the cache early because it's no longer the last message.
Okay.
It's just
Okay.
this weird
Yeah.
sort of thing we have to do.
It should be. Why didn't?
It's just
Yeah.
crazy.
Is there?
Okay, we're definitely not leaving that log in here.
Right.
Okay, so let's do the following. I want to just do a double call
Okay.
because I want to know what's happening between, let's do 3. I want to know what's happening between 3 messages with 3 different images. With IMC
Yeah.
sort of turned on. I want to see what's being rebuilt and what isn't. So let's run this, let's do this run. That's better with the cronk there. Okay, it just did 3 images one after the other, all fairly quick.
So
Let me see though. I don't feel like it did 3.
I see buck. Yeah, 3.
Okay. Okay. This time I processed 3 images back to back. I am sort of curious what IMC is doing. What is it sort of keeping in the session? it's needing to rebuild. So if I come back here, well, that's cranking that out. I'm logging the file, right?
Yeah.
I should see image file in here.
Yep. There it is.
So we did 10, 6, and 7.
It was dope buck.
I'm just super curious if I see the word rebuild. I don't see a rebuild. Okay. Each request has 3 messages. IMC decides to cache message system plus image and treat message 2 as the suffix that triggers generation. 48 text tokens of the templated system plus user prefix. The image embedding decoded into KV via the encoder. 3 channel, all keyed by a hash plus the external snapshot. Image 10, build from scratch. Good. Allocate 68 megabyte snapshot buffer for the first time. Request 2. Scan finds session 0 mismatch. Good. Different image bytes. Different prefix hash. Evicting. That's what I want. LOU session wipes the previous out. Rebuilds the full media cache from scratch. Good. 1 image encoding for 2. So we're not really using IMC at any level then. Buff action reuse. The 68 snapshot buffer survives the eviction and is reused. But just the buffer, right? So I need to double check that we're cleaning that buffer out. Time to first token. Another mismatch. Different image. Evicting.
This says buffer. Buffer capacities reused.
For this workload, IMC is doing nearly 0 KV reuse across requests. The image is the second message and its bytes change every time, so the prefix hash changes every time. The 2-tier fallback that would preserve the system prompts KV. The 2-tier fallback that would preserve the system prompts skipped when there's media. So even though the template system are identical, so ideally we want to turn that off anyway. Yeah, we want to turn that off anyway. Okay, you're right. Okay. So that's good. And
So basically, IMC wasn't really doing
I'm
anything.
assuming we just, yeah, couldn't have. I'm assuming we just mean we reuse that memory buffer. Do we zero out that buffer before use? Now, I have to tell Ed then that is actually slowing you down, not helping. So ideally, in this particular case, we really want to turn this off and don't want anything to do with it. Yeah, I know. They don't. I always feel ugly when we're not cleaning, but they are using a length. Okay. So for sure, I have to tell Ed that he wants to run with turning that off. Now, the next thing that we do, I'm going to turn that off. It's running pretty damn fast.
It is.
Let's, you know, you can do this and go.
What is the underscore? Like
It's just
what?
a readability.
Okay.
So if you're dealing with, you want to like write 1,000,000,
Yeah, you would do.
you can
2
do
cents.
this, but who knows where the zeros end.
Oh, okay.
It's just a readability.
That's nice.
Yeah, it's kind of cool. Okay. Let's run 1,000 now.
Oh boy. It's gonna be a lot of logs.
Whatever. Just writing to stand it out. It's kind of consumed.
But if there's an error, it's gonna stop.
Yes.
Okay.
Because we failed that call. Now, the next step, I'm not going to sit here and do 1,000 because even though it's happening super fast,
It's still gonna take
some
probably
time.
1,000
The next
seconds.
thing is to try to do this across 2 slots to maybe speed up the bug. But at a bare minimum, you know, I gotta tell Ed, at a bare minimum, in some early, I'm just writing a message to Ed, early research, you want to turn this off. Okay.
It's doing it really fast.
Yeah, my fan is on, but it's not like horrible just yet.
Definitely speeding up.
Okay, so this is sort of just cranking out, right? As expected. I'm not seeing any errors. I probably could have looked just at response.
113, 14.
The fact that it's just
15.
returning one word every time is crazy to me. Anyway,
Yeah, there's like no variance at all.
it's really doing well there, right? We probably should have written out what number we're at as well, as it sort of cranks, right? So I'm in this loop. Image file.
Yeah, so we need to track the index.
Maybe we do something like that.
Yep.
Just tack that in there for the next run, and then we'll have a general idea of where we're at. And what might also be nice is, you know, me,
Stars.
I can see them easier.
I feel like we should do it for the result too. Yeah. Give us
Okay.
some breakpoints.
So this thing is just cranking out, no problem. Ba boom, ba boom. What might be also interesting to look at is memory here, right? Are we stabilized at this 50 something?
58. Yeah.
Is it growing? Do we have a leak? Is what Ed's experiencing at some point over time? So memory used. we're at 112. We're at 5820 there.
It went down just now.
Yeah, so what's happening is Go is allocating memory,
Yeah.
and it's asking memory from the operating system. At some point, the scavenger turns on and says, hey, I don't need this memory anymore, so you can have it back.
Gotcha.
Now, the operating system, on its own sweet time, can decide whether or not to take it back. But if it does, then you would see some sort of stability in a drop. I'm seeing stability here, right? We're staying in this 112 number. This hasn't gotten to 59.
No.
Right? It's at 58 here, even though you may not be able to read it. This is basically holding. So even if there was a leak, now this is at 113, but it just dropped back down to 112.
If there was a leak, we'd see like a big jump.
If it's a tiny leak, this will take hours at some level, like what Ed thinks he's experiencing. If it's a nasty leak, then it will just go down constantly, and it will never come. It will just go up. Constantly, and it will never come back down. But you see, this is basically stabilizing, and we use memory buffers for images. And so we allocate what we need, and then we just keep it and we reuse that. That's what we were reading.
Okay.
So there isn't a lot of GC happening per se, because we're just reusing these large blocks of memory.
Gotcha.
Now you're allocating that memory, but you're not seeing big swings. And we're seeing that, right? This is staying under 113. That's staying under 59. This hasn't crashed yet. And it's just like really cranking this out sort of fast.
We just touched 59 and then it dropped back down.
Right, we went over, I saw 115, but we just dropped again to 112. So there may have been a GC that happened, and then the scavenger kicked in, and the operating system took some memory back. So nothing here right now. No, I just saw that. It went to like
117 for a second.
But that doesn't happen on the screen. Now it's back at 113. That's hovering under 60.
Yeah, you can see it good on the stream.
I don't know if there's a way to make this bigger.
Maybe like command plus it, or
yeah, there's no way to make it.
Zoom. Oh, that did not zoom at all. That just expanded it.
Yeah, it's mostly expanded. I didn't make the text any bigger.
No.
No, it is what it is.
You can see it though. It looks like a normal, like if you had it right there.
But I feel like this is...
It is slowly...
Yeah, but it's coming back down.
Yeah.
And with these images, we're basically reusing all that memory. Like this hasn't popped over 60. And this hasn't crashed. So, first of all, this is impressive, right?
Yeah.
All right. Cranking this through the model, and so this is something else I'm going to have to tell Ed to do, is to keep this up and look at, those numbers there. But if we reduce the size of the context window, for sure, that's going to help. So let me stop this for a second. All right.
Concurrency now.
And we should see all this sort of come down now, right? And the other thing I would argue is that the context window is way too big for what we're doing. So with context window, we probably don't need more than, I probably don't even need
32K.
a 32K window, because the image doesn't go into the context window. It's just the two sort of prompts, right? So my guess is, even with that, let's run it like this, okay? And then watch what happens before we do the other thing. So look at the massive reduction in
Oh yeah.
in memory.
Whoa.
And this is going to work just fine.
Image 6.
So I'm going to also have to tell Ed that you want to add this as well. Okay, let's see. I'm just telling Ed I'm cranking images right now.
Yeah, it's 3 gigabytes compared to 50, almost 60.
Just you won't trust me. Trust me on these 2 settings, please. This will reduce a large amount of memory. Because now you'll only use about
It's 4 gigabytes.
5 gig there,
Yeah.
and yeah. So, and this is cranking them out pretty good.
Now, do you think it affects like the accuracy?
No, it can't, because we're just saying how many tokens do we need to cache for both input and output. His output is stupid small,
Yeah.
and the image doesn't really count towards tokens,
Oh, okay. Why
just
not?
the text, because they have to be processed in a different way.
Oh, okay.
He's arguing with me. Like, why are we? We'll make things more stable. Anyway, okay, so I'm gonna add some parallelism to this. We'll try to like do this where we're doing like 2 at a time.
Okay.
Why is he arguing with me? He thinks that when he turned IMC off, things got less stable, but the reality is that's almost impossible because that code path is 10,000 times simpler.
IMC wasn't even really doing anything though.
IMC, if anything, it was causing problems because we had to like reset everything every time. So those 2 things are good, and I can tell him also. And add this for the logging. Okay, now I'm gonna let this thing run while we make these next code changes
Okay.
here, okay? Ideally, if I add another slot, we should be able to do 2 at a time and be able to queue up 4 at a time, really, and have 2 pending for the next call. And we should be able to iterate through this even faster. Now,
I feel like it's faster right now than it was before, with just the context change.
Say it again?
That it seems like it's a lot faster.
It could
now.
be faster too because there's less memory involved,
Yeah.
and it will go faster with the context window change.
It definitely looks faster.
Okay, so let's let that run. There's a few things we're going to have to do in order to sort of pull this off. If you remember in the app log, if it finds a trace ID in the context, it will log that.
Okay.
Okay, so I'm going to want to do that sort of first in here. So what we'll do is before we make this call, we'll do a app log set trace ID into the context, do uid.new string,
Okay.
and context in, context out. Now we'll have a trace ID. So we'll see a unique sort of log flow now for that. Okay.
Okay.
Next, we're ranging over 1,000, but ideally it would be better to process. In other words, if I do this, model.with n sequence, where is it? And sequence max 2. This basically means I'm going to create 2 slots that we can be processing requests across.
Okay.
All right. So, but to set that up right, we're going to have to make a few changes here. Ideally, what we should do is define like a pool of Go routines that are going to do this work.
Okay.
So what I can do is say channel make, a string is the value, chan string, and let's just say that we say right now 4. It means I can put 4 things into this loop at a time.
Okay.
Because there could be thousands of that, and we'll just stage 4 at a time. Then what I can do is create, even if I orphan it, that's fine. We can create a set of Go routines where the Go routines, now the king is how many are we going to create here? So what if we said 4 range, let's do a constant for a second, g equals 4. G, 4 range, G, and this is going to create 4 Go routines for us. Boom, 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 boom. And I don't have any real way to sort of shut this down just yet, but I'll deal with that in a second. Now, the idea would be that you get an image file from the channel, okay? And in fact, this can even be a 4 range. So 4 range on the, so 4 image file range over the channel. So then what you're doing is you're blocking here, waiting for an image file to be sent into the channel. And then when you get that image file, essentially all this work you're going to do. So let's see how that plays out for a second. Image file, I'm not going to have this information anymore. I'm not going to have this anymore. Image file. That's your image file that you're reading in. Now, if this Go routine just completely fails, what we're going to have to do is func.printf this. And then what we could do is just an OS exit to just kill this thing, because I don't know enough yet. Right? That shouldn't be failing. Okay. Then you're going to do this. Then you're going to do this. And I want the context in play here, but we'll deal with that in a second. Then I got my context, set my trace ID, do this. I'll have the same problem here. Printf /n. I'm just going to OS exit this thing and just kill it. Which is bad, but I'll think about this in a second.
Okay.
It would be nice right at the very beginning to do a trace ID here, right?
Mm-hmm.
And then the trace ID is going to look like trace ID, trace ID, %s, image file, just so we have it also in the logs,
Yeah.
right? Okay. And we do the same thing here. This now has to be an F /n. Get our trace ID logged there. We'll do the same thing here. With our trace ID here. Nice. And then our trace ID goes in here. And then boom, 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 right? But we're just
Okay.
killing this if it automatically fails.
Okay.
Ideally, it would be nice to handle this more gracefully, but right now I'm just hacking on something here. So now we just have to feed these 4 Go routines sort of the work to do, okay?
Okay.
And essentially, that's what this is going to do. So we're going to do a channel send into image files sub I. So for as long as there's room in here,
In the channel.
in the channel, this will just keep pushing up to 1,000.
Image files.
And then it will just sort of return. Now,
Okay.
we're not waiting for the last bit of work to get done, so we'll deal with that in a second. And this, oh yeah, we can't do a defer here. What we need to do is essentially just call cancel here. All right, and we create a new one. And all that is fine. Ideally, even, we can just move some of this stuff up here. So we create a context, we set the ID in it. We'll just cancel this because we're doing an OS exit right now. That won't matter. But let's do that last piece for when we pass in the last thing in the channel. So once that's done, you would essentially close the channel. That will allow all these loops to start to end, but we won't know if that's done. So what I can also do is add a sync.wait group.
Okay.
Defer done. So when this loop ends, we'll defer the done on that. We have to do an add. So we can do add G. Doing this old school. So we're gonna have 4 Go routines. We'll do the defer done, and then after you do a close, we can do a wait. And we wait for all those Go routines to sort of end. And what we can also do, just to have some more visibility, and we'll test it. Bump dot print line. We won't have a trace ID here, but just be cutting down G. And we should see 4 of those, right? Okay. Fine. Okay, so this is good. This is fine. We could, even if we wanted to, can see which
which
0 through whatever is sort
Yeah.
of running, right?
that'll give us the go routine.
Yeah, we can
Which
just
one?
make sure that that's also sort of working, right? All right. The nice thing here is we'll have that here too. I'll switch that to an F. Okay. So that's kind of cool. Now, if anything fails, we're just killing immediately, and that's fine right now. But it would be good. We didn't put that in here, did we? We didn't put that in there, did we? Where's the other place it could fail? Here.
Right there. Yep.
Okay, not a bad little hack, I would say. This thing is not failing, right? Let me shut it down. Oh, should have looked at memory. Yeah, the memory's stabled. So all that looks really good.
What count did we end up on there?
Oh, that's a good question.
We should say it on the result, I think, right? Or the image file. 90.
We almost finished all of
Almost.
them.
Almost.
Almost 1,000 of them. What I want to see is if this thing shuts down now. So we're not going to try to do 1,000 at this point. We're going to let's just do 8. All right. And we should see it sort of shut down cleanly.
Okay.
Okay.
Like once it finishes, it'll
Yeah,
shut down.
once it does 8.
Shut down.
Okay, so we see a shutting down G3, a shutting down 1, shutting down 0, and we wait it. Ah, that was perfect.
Yeah.
Okay, unloading cronk, blah, 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 and we're good. Okay, so we've got a cool little program now that is, from a concurrency perspective, pretty solid for what we want to do. Also, it looks like if we look at and we have tracing IDs now, right?
Yep.
What's interesting is, on these we don't do a bracket, just for consistency. We don't do a bracket on the regular thing. So let's get rid of the bracket there.
The space.
Oh, screwed that up, huh? Could have searched for that too. Okay. Just to be consistent. Okay. So all that is good. And it looks like all that sort of worked also, didn't it?
Yeah.
So now what we're doing is we're handling basically 2 in parallel with 2 always sort of queued up, ready to go. So 2 will be running, 2 will be sort of waiting in queue behind the work that we do in cronk for all this concurrency.
Okay.
And this time we'll go back to 1,000, and hopefully the ship blows up.
So should we be expecting almost twice as fast?
Oh yeah, because now we're doing 2 in parallel at a time.
Oh yeah, that looks faster.
And I
There's a
told
lot
Ed
more.
too, we could do this in parallel. Seven is a none. Oh, no. I was wrong. I'd have to look. I was looking at 7 as the next option. No, 7 was a none. Like, this is the next deer, but I have to look at, see, it said, we have to look at the end of this, right? This trace ID for,
Oh, okay.
for 7. Right? And it did come back and say bug.
For 7.
Yeah, because I read this line, which is the next one.
But it. Oh.
This isn't associated with this. It's a new trace ID.
Yeah, because that one's 6.
Yeah.
So we do have a buggy bug.
No, there's no bug. This is the final output of that context.
Oh, for 7.
This
yes.
is the new one.
Okay.
I was being a dumbass. So this one, none, was for 6.
That's why trace IDs come in handy.
Ooh, that's not good though. I'd say that
Was
was bad. It said it processed number 6. So this might be a buggy bug, right?
Okay, trace ID.
And it said none.
But it's for a different trace ID. You have it. You have 6 highlighted right now.
Oh.
So where's the bug?
Okay, no, it did work. Got all this concurrency going on. It did work.
It did. It did.
Huh.
6% of 8K. Of 8K.
I don't know what that means.
I don't understand the down before.
Oh, 6% of your context window is being used.
Yeah.
Even 8K is too big, right?
So we could go even smaller.
We could, but all right, bro. So this
I
is
wonder
just
where-
cranking it out, bro.
Wonder where it's at already.
I know we didn't log. We should have logged.
I thought there was a count. Well, file.
No, because now we're just feeding the Go routine.
Oh.
So I would have had to put a count. Here, if we really wanted to.
Yep.
Something like that.
Yep. Maybe like name it count or something so we can look it up.
Oh, that's why I used a different marker.
Oh, okay. Okay.
And ideally, if I do this, just completely separate it, but maybe that's not important. This wouldn't have a Go routine or a trace ID anywhere near it. But I'm not going to restart this just yet. So this is cranking, bro.
What does the activity monitor look like? 10. So it
It should have doubled because I have 2 slots.
I think it was around 4 before.
But this is working with that parallelism. I'll have to give Ed this code.
And so how far could you really go with?
How much memory you got?
So you can go.
I can go 8 slots if I have
8,
enough
yeah.
memory. I mean, so this is image 9.
I saw it there. None. None.
Damn, dude, this thing's
Nice.
working, bro. So I think Ed to turn full logging on. I have give them the sample program, but we got to push the log changes that I made.
Yeah.
But we are blind on which one we're up to.
I would assume it's maybe almost halfway.
I don't know. I don't know because we didn't log that information.
It's running
However, this thing is running really well, which is exciting.
like an air conditioner.
It's running like an air conditioner, man. So, I don't think there's much more we can do here. The only thing I can do is just let it run. But it's possible that with these, well, he said that these images failed. That's why I have these images. But I don't know. We didn't change anything. But for sure, I'm not going to leave this logging in this anymore. So this logging is going out. I don't need, where was the logging, dude? Ah, that was line 410. Yeah. So I think all this can go, but I'm keeping this guard in because this guard says if there is a marker and the marker's not the same, or the job prompt and the job prompt contains, we have some weird state here. And this is going to help us find some bugs. Because when that was the case, we were trying to process it and we basically crashed.
Oh, okay.
So I'm going to leave that defensive play in there. And then I'm going to give Ed essentially this code here. And that's the code that is running. And we didn't find a bug today. Shit's running solid.
Moving concurrency and all.
I know, dude. This thing's working beautifully. And every time we spot check one of it, it's right. So here, image 4.
Doe.
Hello there, doe. It's a doe, bro. Even with the sunlight.
It's multiple.
Yeah. But that's what he wanted.
Yep.
So, shit's working.
I'm surprised there's no option for doe and bucks. I would have to pick one.
He only cares about bucks, honestly.
That is true. So.
I mean, unfortunately, he cares about the does. Okay, dude. So, I'm just going to let this 1,000 finish. Should have started a clock on that. Would have been nice to see what number we're at. Compared it to the other run.
Yeah.
Which isn't hard to do. You just change the pool back down to 1. Well, you change it down to even 1 slot. Even those go routines. This runs so fast, it would still crank through all of that.
Interesting.
But these little changes then are good. I'm going to push these two. Not
Yeah.
this program, though. Well, no, the program is interesting to sort of keep.
It is interesting.
You know?
I like the concurrency aspect of it.
I might keep this little program and clean this part up.
I think it's a pretty cool thing to show.
You know, because if one of these go routines, honestly, like the only thing you have to do is you print the error, right?
Mm-hmm.
In fact, if anything, we should add error here. And an error here. Here,
There,
right?
yep.
And then just do a continue. Oh, you need the cancel, unfortunately, but cancel, continue. That would be enough because you just go back to the top and you get the next one and you have the error. Like, that would be good enough. You don't have to kill the go routine at this point.
Gotcha.
You got to cancel the context here. But then this is just a big worker pool. Yeah. So maybe I keep this, but what should we call it then? I have a vision example, but
Mm-hmm. What is the vision example? What is
it's just calling one,
just one image to
Yeah.
analyze it?
but then I'll have to put these deer in here, which I can do, right? So what if we just called this example
Concurrent. Yeah.
a concurrency example, right? I'll add something there. And then ideally, I have to take these images. They're not a lot.
I would
I would what?
like. Why not just put the whole deer directory in there, and then you just go in the directory.
Because I'm an idiot. Bill, code, go, source, GitHub, Ardan Labs, Cronky Cronk, examples, samples, paste. And then, because I don't know if that does what I wanted it to do though. There's a way to run that find on all the subdirectories, and I don't think I did that. Like, okay, it's
Oh,
not
yeah,
that.
it
It did
did.
work. Okay. So that's cool. Then, yeah, I think you add the deer as samples here. And that would mean that now this,
Path is somewhere in there. There it is.
you just need to do that, right? You'll run this from the root. Yeah. And we can add a concurrency here under examples. Concurrency after chat. What is chat? Oh, I don't need this anymore. This would be a concurrency. Concurrency. And I wouldn't use this particular model we're using now. I'd go with this model.
Because of size.
Yeah, because this is a model that we know that they're going to download if somebody just brings it down,
Yeah.
right? And this just finished without any
finished.
issues, bro. So we're going to try to run this again. But we're going to try to do it from here after we do a couple minor cleanup things. Make tidy. Okay. I should have cleaned you up. Whoa. What is it? Okay. No, it was the wrong. Make tidy didn't clean that up, did it? We're gonna have to add. Oops. I have the examples in their own. In their own module system, so it doesn't interfere with SDK users.
Oh, okay.
Because I have some DuckDB stuff in there.
Gotcha.
And you just don't want like DuckDB now to be a dependency when you're using the SDK. So all the examples have their own. This has its own module, so it doesn't leak into the other one.
Gotcha.
Okay, so let's do a couple things though. One other change here. We shouldn't be doing 1,000, right? We can do 20. And let's see if this works using the little model, right? And I'm gonna do it with or without the logging to start. Let's do it without the log. So now I should be able to come here and say make example concurrency.
Yep. Unable to read.
Okay, that's fair. But that should be here. So let's do an L, and it is there. So
From the root.
yeah, you're always running this from the root. Oh, no, we don't run it from the root. We have to be inside of it.
Yeah.
Right. So that means that we've got to come out one. That takes us to examples, and then we can go to samples. No, let's try it again. We're going to be running from inside of here. I go back one. That's examples.
And then samples.
Then I'm in samples deer. So
Then deer, and then
so that should have worked. Let's go back and look at example concurrency. So let's just play it out. So change regular to examples. No reason to be guessing. And then I say, no. Oh, I'm in example.
you just go samples and then deer.
So I'm already in examples. So we can just go samples here. Yeah. Yeah, it would
We have to
help.
back up. Yeah.
So we can clean this up a little bit.
Yeah.
So for an example perspective. So let's get rid of the count. I don't think we need this. We were just kind of looking at that.
Yeah.
I think we can also get rid of
The markers.
those markers for sure.
Yep.
And just double checking. This one I need. Let's see. It's better.
Yeah.
I don't know why we have a gap after none there, but we didn't get it here.
It's only on that one. That's weird.
Every once in a while, on the model response, you know why? Because the model's returning a carriage return. That's why. See, it's never perfect. where's model response here, right? So trim. We can just do a trim here. No, that will never happen.
You can hear the computer processing.
But you can also see here that we got a response that said yes.
Yes, one of the deers has antlers. But this is with the smaller model.
Yeah. Oh, yeah. This is a smaller model, actually. Oh, yeah. Oh, yeah. You're
Like
right.
there it says value 2.
Yeah,
dough.
yeah. But that's fine. Okay, so it's kind of cool.
Yeah, it's not like exact, like some of them say if there's multiple, it'll say value 2.
Yeah.
Cool.
I think we can even get rid of this for the example. But you see, even the small model's not doing terribly bad on any of this, right? You know what we missed here? Just to be complete. Sort of that. If we're gonna do this right, then all of these should have had image in it. All right, let's see. Let's run it one more time. No, that's good. See, now with this little, we can just basically take it down to this. Okay, perfect. It's a nice little example, I think,
I think it's a
to
good
show
one.
a little concurrency and you know, looking at that. Now, here's something that's interesting. All right, and we got this little program here, right? I did all the sort of concurrency myself.
Mm-hmm.
I'm gonna save this work first. I don't know if I have the examples in all the examples in here. We do. So I have to add some stuff here, but why
One
is my
N.
brain shutting down? Oh, that's
One
right.
N. Yep.
Concurrency. Show you how to leverage concurrency using sort of vision models, right? And
We have to change the.
yeah, I gotta change it. I'm just looking at sort of this here, right? The example shows how to create a concurrent chat application against inference models. That's fine. What else did you say we needed to change?
Where were you in the README? The make example. It has to be. Yeah.
Okay, perfect. I'm gonna save this to so I like all of this. I've been working on some slide ideas, so that's fine. some new concurrency example, right? Let's even just push that up, just to my branch. Okay, now this is what I'm curious about. I hacked this out. I'm happy with myself, right?
Mm-hmm.
But hey, review this example program. I wrote this sort of quickly to show how they can sort of leverage batch processing / concurrency in their Go programs. Sort of review the code and give me some suggestions to make this more idiomatic and sort of readable.
Release the AI hound.
Yeah, why not? This frontier, other than it doesn't know all the new Go stuff from like 125 and 6.
Okay.
It's still a better programmer than me. So let's see what it says. Header comment is wrong. Fine, whatever. Copy and paste message. Ooh. Oh, that's on every example.
Oh.
Wait a second. That would be on every example.
Where's that? Oh.
Wait a second.
Oh yeah, there it is.
Okay, we gotta fix that on everyone. Typos, fine. Okay, this one isn't. This is what I was over. I know, that's why I'm having you look at this.
It's being very critical.
It is being very critical. I mean, come on, man. The worker pool is fine and idiomatic. Thank you. I know it's arbitrary.
I'd keep it, but make it less shouty.
All right. Make your suggested changes. However, dickhead. However, no, I'm not gonna say. However, item number 2 is a problem on potentially all the examples. Okay. All right, we're past 1 o'clock.
Oh, where?
We are, but we're just going to finish this and then finish our show. I hope anybody who watched this enjoyed us trying to find a bug that we couldn't reproduce. But you can see how powerful Cronk is and getting logging and all that stuff. And I'm going to move all this stuff to main later today. All right, I want to see what it does here. Come on now. Make me look bad. It liked my concurrency work. That's all I care about.
It did.
Okay? It thought my concurrency work was satisfactory. Just didn't like the way I was naming everything. So let's see the changes that it makes. But this way I can undo them if I don't like them.
Yeah.
Okay, it fixed my buggy bug on all that, which is kind of interesting. which now means while it's still busy, I gotta go into the README, find the example that I put in the README. Oh, I still want to look at if I can get the actual. Actually, I probably can't because when we say auto, it's going to do that. But auto should be. I'm going to have to ask the model that. I don't want to lose this, so I'm going to put it in here. Ask, come on, about auto on KV and seeing the exact value. Okay. Now, that was even small for me. Let's see. It thinks it finished its work. So let's see what it did. Okay. Classify images, fine, whatever. List Bob. It called a function called process image, but it kept everything else that I had here.
Yep. Rename that to num workers.
I'm guessing it put num workers up here.
Yep.
Okay, fine. Nice little cleanup. Defer done, bop. You did this, close, bop. Didn't change any of that. And then I put all this in here, which would allow you to do the defer, cancel, and everything. Okay, that's fair. That was a nice cleanup that I didn't have to do. That was a nice cleanup.
Nice. Yeah.
Beautiful. Okay, so now we've got a new example that we keep with the project for people to look at. All right, we had a good session, so we'll be back here next week on Tuesday. We'll see what we're going to do next, but I think it was a nice sort of. Now I got to convince Ed to make these changes because it's never his problem. It's never his fault.
Yeah.
You know, and I keep telling him to double check the size of the images after he downloads them out of cloud storage, because maybe
There's a limit.
maybe it'll be a limit, but maybe that API is not bringing down every byte. You're not checking a SHA or anything.
Oh, okay.
So then he brings it down for me, and then the second download works or something. So I don't know. We have to work on that. Anyway, thanks everybody for hanging out. Appreciate it. We'll be back next week.